our start presentation. According to market research interest and export, the size the related IoT market is expected grow in 2020 with 5 billion Internet of Things devices from around the world connected. In order to take the in the IoT ecosystem, Rubber is beginning to turn to prevented and standard through technology development. Being used sensor to identity various behavior on the changes in the around things that we doing another delay life piece of our real world are made in the cyber world or cloud world. As the number of objects connected to the internet increased, overpriced digital cost of the real world invades the IoT industry can be divided into platform, service, network, security, and device. First of all, the platform built in global giants such as Google, Microsoft, and SKT are serving to become the leading IoT ecosystem. But there are no operator who has domain in the IoT platform yet, and small to medium-sized completed has site to develop and enter the market to enter the market. The service sector is changing from the biased environment using particular handset and an open ecosystem. Their smartphone can be developed and silenced anywhere. Device that use IoT has limited resource, and IoT device where has small resource and limited communication and environment with domain for long hour of use. Like communication protocol needs for communication for such device protocols, MQTT and COAP, which the use in IoT are receiving attention. We want to compare the two protocol used in IoT. In this paper, we are going to construct a communication environment between devices using MQTT and CoAP, which are communication protocol designed for Internet of Things on the one M2M platform using Arduino and fine dust sensor among open source hardware, and errors and compared to amount of power consumed by which communication protocol. focusing on MQTT. The message is issuance, cycle was included from 1 second to 5 seconds interval to compare the power consumption of the MQTT and COAP protocol with message size of the 2 bytes. It shows peak with the consumption power generation. Approximately 1260 milliwatts for the MQTT, and the large set consumption power at 1405 milliwatts for the COAP. The show is 6 if the message size in at best 100 bytes. Average power contained by about 65 milliwatts on average. COAP increased in about 107.8 milliwatts on 1000 bytes. The management research show in 7 big and show MQTT 71 milliwatts for non-response and quality of service 0, and COAP and 124 milliwatts the generation response from quality of service 1 and COAP. In MQTT, we plot see an increase in power consumption and 143 milliwatts when peak back, and the quality of service 2 and COAP. If the message size is then 100 bytes, the average power contained by varies by about 65 milliwatts on average, and COAP increased to about 178 milliwatts on the 1000 bytes. 1705.2 milliwatts and 1075.4.2 milliwatts on the 5000 bytes. In MQTT, it was found that 71 milliwatts for non-receive at quality of service 0 and COAP, and 124 milliwatts for generation response from quality of service. COAP were concerned reside and MQTT. In MQTT, we from see under increase in power consumption and 104 milliwatts when peak back, and quality of service 2 and COAP. Thank you.